Muy bien. He preparado la presentación en español, pero me indican puedo hablar en inglés.
Mm. Sí,
No.
de preferencia en inglés, pero si prefiere hacerlo en español también está perfecto.
Okay, I am, you give me the option to present in Spanish or in English. I choose Spanish, but I don't mind to speak in English. The only thing is that the presentation is going to be in Spanish. Okay, the title of my presentation is Spatial Patterns and Seasonal Patterns of Climate Teleconnections of about precipitation in three basins in Ecuador where it is a hydroelectric generation of electricity. So as to contextualize the presentation, I will divide in different parts of the title. So I will trying to explain this very long title. First of all, the climate teleconnections and the relation with precipitation or rainfall, what they are. This study is in Ecuador. I guess you already know where is Ecuador, but it's in the north of South America. Is a country where we have the Andean mountains, and these mountains divide the country in two. So the climate teleconnections are relations between two different points, sometimes far away, these points. So what's happening in one part of the planet, and now we talk about the temperature of the sea level specifically, can have an effect in other parts of the planet. So these changes, and we are seeing in the images how in the Pacific Ocean, how the sea level temperature increase when we see red colors, and how it cools down when we see the blue colors. And these have an important effect of the precipitation in several parts of the planet, but I'm going to talk about in Ecuador specifically. So we measure these teleconnections in relation with climate indexes. This climate, for instance, we can define in the figure that is below. We can select parts of the Pacific Ocean or the Atlantic or different parts of the planet, and we will measure one climate variable. For instance, the sea temperature level. So along the Pacific Ocean, we have a climate index that is just in front of the Pacific, of the Ecuador coast, and we have different areas as we move to the west in the Pacific. And these climate teleconnections are very related with the famous event of the Niño and La Niña. As a second point to talk about is what is the relation of this climate teleconnection with hydropower generation. And mainly because we can produce hydroelectric energy if we have the availability of water. So mainly from rainfall, but it's also another characteristics of the regions such as evapotranspiration, runoff, and from the rivers, how much water we can have available. And other important also is how much energy we can produce, but also how much energy we will demand to have. And this is very related with waves of cold and hot waves. So know and understand this availability of water and how it is related with this climate variability, with natural climate variability. Is really important to know how much energy we will produce from the water, and how we can know that these resources we will available along the time. As a third, and this is the last, I don't know, it's not the last, it's the previous one until finish this contextualization part, is that we want to define these spatial patterns, how these teleconnections have an influence on the Ecuador, spatially, but also in the different seasons along the year, more or less in the different months. So to measure precipitation, we have two options or two information available. From one side, we have the meteorological stations, and here we are some meteorological that we have in Ecuador. So this information gives to us punctual information, so information in a point. And we have a few points, few observation points in very big extensions in the territory. So we will have always some gaps in the space and also gaps in the time. Sometimes they broke down or we cannot collect the data, and the data is loose, so we cannot have a complete time series. On the other side, we have satellite images that they are, I would say, not a new technology, but we have longer time series with meteorological stations than from satellite images that more or less started to be available around the 1980 and many others satellite products in the 90s. And the main advantage of this information is that we have a continuous informations in the territory, and we don't have gaps in the time series. But the counter side is that the pixel size of the spatial resolution is somehow scarce. So we have pixels of 5 to 30 kilometers. And finally, a little bit about Ecuador. Is a tropical country, so we have a high amount of precipitation, not all the year, but we have rain mainly in the coast, in the Pacific coast, in the first month of the year, and in the Amazon. That this part is also belongs to the Amazon rainforest. Most of the year we have a very high precipitation rates. So we selected 3 hydrological basins in which we have hydropower generation. One, and they are located in different geographical and climate areas in the country. We select one basin that is called Jubones Basin that is in the coast, and this is a Pacific basin. So all the water that is collected here runs to the Pacific Ocean. The second basin is called Paute Basin, and this is located very high in the Andes, from 3,000 meters above the sea level, and it goes down to the Amazon rainforest. So this is an Atlantic basin. All the water that is collected here run off to the Amazon river. So even though we are very close to the Pacific, it belongs to the Amazon basin. And finally, the Napo basin, that is the biggest one, is really an Amazon basin. The research problem is that these climate teleconnections really depends on the place that we are located. So there is not the same the climate teleconnection that we can find for Ecuador than for Mexico, for instance, and they make evidence in specific periods of time and in the seasons of precipitation also. So related with climate indices, we have previous studies in Ecuador, but they mainly attended the ENSO-related indices, and mainly this region that is called Niño 1-2, that is close to the Ecuadorian coast. But this is needed to explore more indices. About the regions of the country that were studied, mainly the studies address in the Pacific coast, but very few in the Andes and even less in the Amazon rainforest. And finally, most of the studies uses a meteorological station. So we have the information in a point, but we don't know how this teleconnection is spread in the territory or how they vary in the space. So our research objective was to identify these relations in space and in time with climate indices in these three hydropower basins. We used one type of satellite images of precipitation that they are called CHIRPs. We choose them because they have a spatial resolution of 5 kilometers. And we also related with climate indices from the Atlantic and the Pacific Ocean. So from one side, we have time series from the climate indices, and from the other side, we have these spatial temporal cubes that are formed with these satellite images. The methods for the analysis, I have to say that they are quite simple. They are a correlation analysis with Spearman a correlation that is a non-parametric correlation. We prepare the data eliminating the trend, the temporal trend in the time series, and we apply this method pixel-wise. So pixel to pixel, we made a correlation between the climate index and the time series of the precipitation. So the results that we found are mainly summarizing in this table. I will I use a color code that we explain so we can follow the explanation. We use red colors for the negative relations, so negative correlations, and a strong red color for a strong relation, and a lighter for a moderate correlations. And the blue is similar, but for the positive correlation. So this means that with our climate index presents, for instance, higher values, we also are expecting to have higher precipitation. So this is a positive relation. So the first part relates to the Pacific Ocean, that mainly we see red colors. So we find that when the temperature of, in this case, the index that are related with the temperature presents more higher values than the normal values, then precipitations decrease in most of the country. And below we see from the Atlantic Ocean that we mainly have blue colors, but with a moderate strength. And relating to the three basins, Jubones, some parts of the year we have a more blue colors, and in the other two, more red colors. So we'll briefly explain the main results in each basin. Starting with Jubones basin, we see that in the first two seasons, in the first semester, we have January, February, March, April, May, and June. We have red colors, and we select two types of index. The Niño 1-2, that is the one is very close to the Ecuadorian coast, and TNI, that is related to, it involves the sea level temperature in front of Ecuador, and also in the most west part of the Pacific Ocean. So it is a gradient or a difference between this east and part side of the Pacific Ocean. So we see that this teleconnection is present in most of the country. So it is present all above the basins. No, sorry, not the country, but the basins. From the hydroelectric point of view, we can see that we will have more water availability or more precipitations when we have positive anomalies in front of the Pacific, in the front of the Pacific coast of Ecuador. But in July, August, and September, we change this relation for a negative one. And we select as the strongest one, the Niño 4, that is the sea level temperature close to Australia, more or less in the west part of the ocean. And we also see that we have a spread in most of the basin. Going for the Paute basin, I select this index TNI because it shows the strongest and with correlation higher than 0.6, and it spread all the basin, but it only has an influence in the first semester of the year. We also have in July, August, and September a relation with most of the index that are in the Pacific Ocean. Now I focus this presentation in the Pacific indexes because they are the strongest one. Even if we have some relations with the Atlantic one, they are moderate relationships. And finally, in NAPO, we have this negative influence for the Pacific, like reducing the precipitation when we see temperatures above the normal values. And mainly, they are not related with the Pacific Ocean close to Ecuador, but more with the middle to the west region of the Ecuador, of the Pacific Ocean. And also this relation in the territory, we don't have an influence in the whole basin, but in the west part. And this west part is related with the highlands of the Amazon rainforest. So far, I show several numbers and regions, but they were analyzing one-to-one. So one index and the analysis is completely separated from the other index. But these teleconnections are present at the same times and in the same places. So here we make a very straightforward maps about these possible interactions between the teleconnections, and we show with the higher colors in blue the positive relations and in red the negative relations. So where we see the stronger colors or the darker colors, that means that there we have more teleconnections that are affecting at the same time. So sometimes when we see that one index have an influence, it doesn't mean that if we have the influence of another index that they make the double of the relation. See? Okay, just to finalize the presentation, some general conclusions that this study had a direct contribution to identify the main or the most important teleconnections for these study areas. We also provide the maps to showing where these teleconnections have an effect. And we identify the main seasonalities because the effects are not the same along the year. And these interactions among the index is a really important point to further study. This is also mentioned in the limitations that we need to go deeper to these interactions and maybe also to explore another types of correlations. And we also would like to extend the temporal time series and to work with lower spatial resolutions, but that implies to go for downscaling methods for the satellite images. And this type of study, even though I showed for Ecuador, but the methodology and the idea can be applied for different parts, and this provide us to information to assure that or to know how much water we will have in the future, and it's going to depend on what. Also, it's an important tool to develop early warning systems to know how we can manage the water resources in order to continue providing hydroelectric power generations. And this also gives us some information in order to anticipate the climate change patterns, because one of the expected changes is, at least in this region of the planet, we will have like an El Niño event more frequent than before. So knowing how this ENSO and related index influence Ecuador, it will also prepare to know how to manage climate change. Thank you a lot for your attention.
Thank you so much for your presentation. We don't have much time for questions right now as we're moving on to the next part of the presentation, but we appreciate what you showed us today. Dr. Felix as well personally gives you his regards. He was not able to participate as he's busy with the other parts of the conference, but he's thankful for your presentation as well.
Okay, thank you very much.